So we have some other concepts as well, as such as restriction on composition. So proportion of one product cannot exceed a particular percentage. For this we are taking the mining example. So here we have so in this problem we have two shafts, S1 and S2. So this will be our decision variables, and the capability is we can extract maximum of 3000 tons from shaft 1 and 5000 tons from shaft 2. But we have been given like there is some impurities, 50% impurities from shaft 1 and 75% impurities from shaft 2, which means we have 0.5 purity from shaft 1 and 0.25 purity from shaft 2. It is also being given that the cleaning process can handle 7000 tons only. So regarding the constraint, we can write S1 should be less than equal to 3000, S2 should be less than equal to 5000. The combination of both should be less than equal to 7000. But it is also given like this cleaning process can handle 55% impurity only. So let's say we are making a mixture of both, and this is where the concept of proportion comes to play. So here we know that we get 0.5 S1 impurity and we get 0.75 impurity from S2, and the weight of the whole mixture is S1 plus S2, and this should be less than equal to 0.55. So our constraints are 1, 2, 3 and 4. Now it is obvious that S1 and S2 should be greater than equal to 0. And now talking about the objective function. So objective function, we want to maximize the amount of purity from these two shafts. So 0.5 S1 plus 0.25 S2, we need to maximize this. Now all these equations we can easily solve them in Excel. Regarding this, as in my previous video I have told you, you can simply transfer these to this side and then you can solve it. So let me show it to you. S1 plus 0.75 S2 is less than equal to 0.55 S1 plus 0.55 S2. Putting it on the other side, we have minus 0.5 S1 plus 0.2 S2 should be less than equal to 0. So this is the equation that we have to put in the Excel in order to get the solution. Another problem that we may face is the modeling of min-max, which states that larger of the two function is the smallest possible. So for this we are taking a transportation problem in which instead of the usual reducing the cost, we need to reduce the time. So here we are given the time that will take from sending the materials from the go down the warehouse to the destination. So here we have the supplies and we have the demands, and they are balanced. So this whether problem is balanced or not, we will discuss it later, but here we can simply take 4 decision variables. So let's say those are X AP, X AR, X BP and X BR. So as the name suggests, it will originate from Ambapur and will reach Palampur. Similarly, it will start from Ambapur and reach Rampur, and so on. So here we have some restrictions. So this is the decision variable. Let's talk about the constraints. So we know that Ambapur can supply only 10 truckloads. So XAP plus XAR should be less than equal to 10. Similarly, XBP plus XBR should be less than equal to 4. This is the supply constraints. Now talking about the demand constraint, so Palampur requires 6 truckloads. So from the point of view of Palampur, we have XAP plus XBP should be greater than equal to 6, and XAR plus XBR should be greater than equal to 8. Although this is balanced, but it is advisable to use the inequality. So from a supply point of view, you can't supply more than that. That's why we are taking the less than equal to sign, whereas for the demand, at least that much demand has to be fulfilled. That's why we are taking the other sign. So now these constraints are done. Now talking about the objective function. So here the concept, because like the min max concept is, let's say we are concerned with the destination only, and both of these like their demands are fulfilling in parallel. So let's say Palampur and Rampur. Palampur receives all its demand in 20 hours, and Rampur receives it in 18 hours. So here these are happening in parallel. So the first 18 hours both are getting their supply, and once after 18 hours its requirements are fulfilled, and still for 2 more hours Palampur is getting the supply from the godowns. So here if we talk about the total time that has been taken in order to complete the order, so we can't simply add those because these are happening in parallel. So we will take the maximum of both of these, so that would be this one, 20 hours. So this is the concept. Now for this, what are the objective function? So from Palampur point of view, this is the component, and for Rampur point of view, this is the component. So these are two independent functions, but we are concerned with the one which is going to be of the greater value. So this is just an example, but here it is Palampur. So we will, once we know which one is taking the maximum value, we will be concerned with that, and then we are going to simply minimize that one, because if the maximum let's say once we know that Palampur was taking more time, and according to us it has taken 20 hours, but if we are able to reduce it to, let's say, 18.5 or 19, so that would be the minimum possible hours that the whole supply process will take. So this is what we are concerned with. So this could be written as min max, so maximum of these two and then minimizing that value. So but when we have to solve this in Excel, we will simply assume like whatever the maximum among these two is a value t, and then we have to minimize this t, because in Excel we can have a single objective function only, we can't have multiple objective functions. So this needs to be incorporated in the equations. And one more thing, we can't simply add this, because here the objective function is to reduce the time, so we have to multiply the time component here as well. So for AP it took 6 hours, for AR it took 5 hours, BP 7, and BR 8. And now since we have told like the maximum of these two is the value t, so we can write a inequality equation 6AP plus 7 XBP will be less than equal to t, and similarly 5ar plus 8br will be also less than equal to t only. So let's say this was the one which was having the maximum value. So if we just replace t with this value, here the equality sign will hold, and here since it is the bigger of the both value, so here the less than sign will hold. So now using this, so actually decision variable we will have one more, that would be t as well. So let me show this in Excel how we are going to solve this. So here is the time that is been given to us, and now we are taking the decision variables. So randomly I can take any value. So I have just taken one. Now talking about the constraints. So here we have six constraints, and so it's simply XAP for the first one is 1, then XAR is 1, the value should be less than 10, C2 it's going to be the other way around, then so this is simply just translating those inequalities that we have written into a matrix so that we can use the sum product later on. Now talking about the cost, so here we have 6 AP and then 7 BP, and regarding that inequality, the t was on the right side. If we move it to the left side, it will just have a -1 coefficient with it. The same would be for the other inequality as well, but here the prices are concerned with Rampur, so I am just putting in those values. Okay, and regarding these, here those, since there is nothing on the right hand side, the values would be 0. Now the inequality sign, those are important. And here we can simply use the sum product. Here I am just fixing these values because we have to multiply the same array. Okay, so this is done. Like we are concerned with t only. T was the maximum of the two expressions that we have, and then we have to minimize that. So if we talk from a, because even objective function have a objective coefficients as well. So regarding the objective coefficients, all others would have 0 coefficient and this will have 1. So simply objective function would be sum product of these decision variables with these objective coefficients. Now let's try to solve this using the solver. So objective function is this, we need to minimize this. The decision variable are all of these, and now talking about the constraint, so the same So now we are adding the constraints. All those with the same inequality could be clubbed together. Now since there are no more constraints that needs to be added, we can simply press OK instead of add. We will select the Simplex LP model and then we will solve it. So here we get it as 40. So this is our answer.